Intermediate Algebra for Statistics, using function notation with linear models. Lesson objectives: use function notation to make estimates and predictions. Find the intercepts of a model. Lesson objective: use an equation of a linear model to make predictions. When making a prediction about the dependent variable of a linear model, substitute a chosen value for the independent variable in the model and solve for the dependent variable. When making a prediction about the independent variable of a linear model, substitute a chosen value for the dependent variable in the model and solve for the independent variable. 4 steps modeling process. To find a linear model and make predictions. Number 1, create a scattergram of the data to determine whether there is a non-vertical line that comes close to the data points. Number 2, find an equation of your model. Number 3, verify your equation by checking that the graph of your model comes close to all the data points. Number 4, use the equation of your model to make estimates, make predictions, and draw conclusions. Example 1. Table 38 shows the average salaries of professors at public college and universities. Let S be the professor's average salary and thousands of dollars at T years since 1980. A possible model is S equals 1.79 T plus 22.50. Number 1, verify that the function S equals 1.79 T plus 22.5 models the data well. Number 2, rewrite the equation with the function name F. Number 3, predict the average salary in 2013. Number 4, predict when the average salary will be $85,000. Solution. Number 1, we draw the graph of the model and the scattergram of the data in the same viewing window. The function appears to model the data well. Number 2, we use the function name f, so we substitute f of t for s in the equation s equals 1.79 t plus 22.5. So here's our equation and function notation. Number 3, for the year 2013, x will be equal to 33. We take 2013 and we subtract it from 1980 because x is how many years beyond 1980. F of 33 would be equal to 1.79 times 33 plus 22.5. We have to multiply before we add, and we get 81.57. So what does this mean in the terms of the problem? We would say, according to the model, the average salary will be $81,570 in 2013. Number 4, we substitute 85 for f of t in the equation g of t equals 1.79 t plus 22.5, and we solve for t. So we have 85 equals 1.79 t plus 22.5. Now we have to subtract 22.5, and we get 62.5 equals 1.79 times t. Now we divide by 1.79, and we see t is approximately 34.92, rounded to 2 decimal places. So what does this mean in the terms of the problem? According to the model, the average salary will be $85,000 in the year 2015. So we round t off to 35 and we add it to 1980 and we get 2015. We can verify our work in both problems 3 and 4 by using a graphing calculator table, or we can graphically verify it by using the trace feature. So using the table, or we could graph it, then hit the trace button and pick these values. So the answers are verified. Lesson objective. Suppose a function of the form p equals m times t plus b, where m does not equal 0, is used to model a situation. Then the p-intercept is 0b. To find the t-coordinate of the t-intercept, we substitute 0 for p in the equation and solve for t. Let's do an example. Example 2. Cigarette smoking has been on decline for the past several decades. Let P be the percentage of American adults who smoke at T years since 1900. Find a linear model for this data set. So we have our table here. So the first thing we want to do is to grab our graphing calculator, hit stat, and then enter. The independent variable is the number of years since 1900, so we're going to enter in 70, 80, 90, 100, 105. And then in list 2 is our dependent variable, which is the percentage. Next we hit stat, use the right arrow key to calculate, and then number 4, linear regression. And then we have our line of best fit. So we would say P equals negative 0.52 T plus 73.84, rounded to 2 decimal places. Number 2, verify that the function models the data well. Number 3, rewrite the equation with the function name g. Find g of 114. What does the result mean in this situation? Number 5, find the value of t when g of t equals 30. What does it mean in this situation? Number 6, find the p-intercept of the model. What does it mean in this situation? Number 7, find the t-intercept. What does it mean in this situation? Number 2, we draw the graph of the model and the scattergram of the data in the same viewing window. So you hit second, y equals, which is stat plot. Make sure the plot is on. Then you hit the y equals. You type in the equation, negative 0.52x plus 73.84. Then you hit zoom, and then number 9, zoom stat. The function appears to model the data well. Number 3, we want to use the function name g, so we substitute g of t, because t is our independent variable for p, and we have g of t equals negative 0.52 t plus 73.84. Number 4, to find g of 114, we substitute 114 for t. We multiply these two first, then add, and we get 14.56. So what does this mean in this situation? We would say, according to the model, 14.6% of Americans will smoke in 2014. Number 5, we substitute 30 in for g of t and solve for t. So we have 30 equals negative 0.52 t plus 73.84. We subtract 73.84 to both sides of the equation. We end up with negative 43.84 equals negative 0.52 t. Divide by a negative 0.52. Negative divided by negative is positive. And we have t is approximately 84.31. So we would say the model estimates that 30% of Americans smoked in 1984. Number 6, G of t is in the form y equals mx plus b, so 73.84 is the p-intercept. So the model estimates that about 73.84 of the American adults smoked in 1900. Research would show that this estimate's too high. Model breakdown has occurred. Number 7, to find the t-intercept, we substitute 0 for g of t and we solve for t. So solving this equation, we see that t is equal to 142. So in the terms of this problem, we would say the model predicts that no adults will smoke in 2042. However, common sense suggests that this event probably won't occur. So we're likely to have model breakdown again. Thanks for watching.